Hello, everyone. Welcome to this very special conversation with Paco Nathan and other people.
Really
Really like to welcome you all who are watching this live. If you didn't see it already, you can chat live. If you have a question for Paco, please chat it there. I'm watching it, and if you have a really good question, we'll ask it. So with no further ado, let me introduce Paco Nathan. He's the managing partner at Derwin. If you want to reach him, he's at derwin.ai/Paco. He has this incredible resume. I always love learning something new about Paco every time I talk to him. Every so often I find something new. Like I think last time we talked, I didn't realize you were in the military. Like Paco actually was in West Point with what was that guy's name? I can never remember his name. The guy who did the LSD experiments.
Oh yeah, well there was we weren't there at the same time, but we did. One of the other notable people to have gone through West Point that I caught up with years later was Timothy Leary, and we were at a multimedia we were at a VR conference together, and we started reminiscing about being in the Army, and his entourage were people that just couldn't believe the words coming out of his mouth. So we literally cleared the room. Like 40 people exited because they couldn't believe that he was talking this way.
So somebody says that there's an echo. Let me double check that we don't. I don't have a problem.
It's on Paco. It's not on yours. Okay. Hopefully that. Oliver, if you can, I think I fixed it. If you could tell me yes or no. Yes, that Timothy Leary story was super interesting. Paco's done all kinds of things. He's been in the neural network, R&D. Since the 80s and 90s, has been in ML. If you didn't already know, Paco has been doing this for a long time, and it's rare to be able to talk to somebody who's done this for a long time. He's also at Databricks. He was there for community evangelism. So currently at Derwin doing DoD projects, which I always find fascinating. And then for the book, he wrote this post, or not the post, he wrote a contribution called The Rule, Not the Exception. In it, he makes the case for having some robust infrastructure. And Paco gets to talk in a second. I'm sorry, I have to give him such a long intro. But he's been a huge influence on me. If you didn't know or you didn't read that part of the book yet, Paco was the biggest reason that I wrote the book. He did the original, I think you did the original work on how do you manage that. You did an O'Reilly video, and I watched that and I thought, we need that same thing for data engineering or the whole system. So thank you, Paco.
Thank you, Jesse. Wow. I'm that warms my heart. I'm very glad to hear about that.
Yeah. And we were talking before how much we miss each other. I haven't seen Paco in person in a while. We used to see each other all the time.
Yeah, no, I think it's almost been, it's about a year ago. We were both in Madrid. We went out to a little cafe, had some cider.
Oh, yes, that was fun. I think that was the last time we was in Barcelona.
Yeah.
Or was it? No, you're right.
Madrid?
I think it was Madrid, yeah. Oh, that was fun.
Yeah.
And such good food. I miss traveling and eating such good food all over the world.
Yeah, I know. Well, we've caught some good spots, and I hope that we get back to a place before too long where we can do that much more.
So one of the things I wanted to talk with you about is some of the early days. I find the early days interesting because we can see how far we've come. One of the things you talked about was you were in the early days of data engineering. You were literally one of the first people to use what became Amazon Web Services. Could you talk more about that?
Yeah, I had been working in network security. So, I mean, I did machine learning work a long time ago. My graduate advisor actually got denied tenure. They said that his work was too empirical, wasn't theoretical enough, because machine learning was just kind of a really small part of AI back then. I went into network engineering. I worked for Bell Labs. I did neural networks for a while, but it was just clear that we weren't gaining enough momentum, that we weren't, there just wasn't enough compute power yet. And I'd worked on some hardware accelerator projects, but still just wasn't there. So I worked in network engineering for years, and later got into some aspects of network security. And I was at a network security startup that was using machine learning. And one of the angel investors went off to Seattle. And that company, we did some stuff, but it eventually got rolled up in something else. This investor kept calling me, and he would ask me these harebrained questions like, if you had XYZ, how would you use it? And I was like, well, nothing like that exists. But we kept talking, and then eventually he's like, well, go check out the following URL and watch it, like next month. So basically I became one of the guinea pigs. And when AWS, I think the first service, there was an e-commerce service that went out earlier, but the first real part of AWS to go out was S3. And then, others came along too, EC2 and others. So I was technical. I got brought in as a technical co-founder for a new startup, and it was right when AWS was launching, and I'd been, told, hey, go check this out. I convinced John Callahan from True Ventures that we should go all in on the cloud. And so as a new startup, don't bother buying up hardware. We're just going to use the cloud to scale out. And the VCs loved it. They were like, yeah, that's a good way to go. They'd never heard of it before, but they were willing to support it. So we went all in, and gosh, there was one of the early meetups for AWS was in 2007 in Santa Monica. And it was back when there was like, or maybe it was even 2008, but there was a huge wildfire going on in LA. And the AWS team, like the leadership was going out trying to do meetups. They were in San Diego. They were trying to figure out if they could fly to LA or not. And if so, was the whole place like burning down because we were going to have a meetup in Santa Monica. Andy Jassy and some of the others were going to come talk. And I was on the ground there, and it was bad, but people were still showing up. So we went ahead with the meetup, and we had like, I think some of the first 3 companies to really start on AWS presented. We got to know each other and just kind of, talk shop. And eventually I did some work with Andy. For what it's worth, he asked me to be a reference customer for one of his big sales leads that he was going to close. Turned out to be SAP. So I got to be the SAP reference customer to say that AWS was like a real thing. Anyway, I'm babbling, but the early days of that, it was clear that Amazon had just like solid engineering, but they also had this idea that they had a clear business model, and they were really going to go after things that had the fundamentals of how they could scale and how they could scale reliably, because that's the value they were bringing to market. So it was really fun to get to work with them.
And do you kick yourself now that you weren't part of that founding team of AWS?
No. The hilarious part was I'd interviewed with him 6 months earlier. That was because that was. So before I went into this technical co-founder in this startup, which by the way we were doing a weird thing. We were scraping social media and doing natural language for building conversational AIs in something called Second Life. And everybody kind of looked at us like we were aliens. Like, why does anybody want a conversational AI? Why are you scraping social media? And so I was working on this startup, but I had gotten recruited by Amazon, and I'd gone up there. They were looking for a new manager for their recommendations team. And so they'd asked me to, interview with the team. And seriously, that was not a job I was going to take. I think we both walked away going, there's no way I'm going to work here. And they were like, there's no way you're going to work here. And so, it was kind of ironic that later on I ended up working with them so closely. One of the first things I did was we were building out these machine learning workflows, and we were running through a lot of data, and we were reaching a lot of bottlenecks, and just things weren't reliable. One of the engineers on my team suggested using a new open source project that had just been released. So we'd started in July that year, and we started using AWS in August. And by December, it was clear that we needed something else. There was a new project that was just released called Hadoop. So we started using Hadoop in the cloud in late 2006. And it was just really fun to see that whole arc of applications on top of AWS. But it was also really interesting to see the ecosystem because AWS was solid and it was great working with them. But I would rather be outside doing applications. On the other hand, though, there was this user group out of Yahoo, and they were going to have this large sort of meetup on steroids called Hadoop Summit. I think this was the second year, and they kept changing look. They were kind of dropping the ball, and it was growing too big for them. So they were having trouble with logistics. So I called up Tracy Laxdal, who was head of marketing at AWS. And I mean, it was a relatively small team at the time. I was just sort of like Tracy was my friend, and it's like, why don't you offer to buy lunch or something? Because I think they really need some help on this event. So Amazon came in as like the first sponsor, outside sponsor for Hadoop Summit because of one phone call.
That's the power of Paco. So we've got a good question from the audience. It's from Francesco Musio. He says, moving to the cloud, what is the biggest challenge to build an effective team?
Oh, that's interesting. So here's where, again, kind of your hypothesis starting out the conversation was about looking at some of the history and origins and, getting some guidelines. When I first met the founding team for Spark and for Databricks, it was at a guest lecture at Berkeley. David Patterson was hosting it. And it was interesting because like the first year of PhDs, Matei Zaharia was one of them. They were mostly network engineers. So I think that to really leverage cloud, you have to understand the kind of trade-offs that are being made and why. And I would say that a lot of that, again, falls back to what I mentioned before. I'd had background in network engineering, and it's kind of obvious why they were doing things like cloud. But I think that message gets lost in a lot of the vendor literature and PR and whatnot of just really where are the engineering trade-offs for being able to use some infrastructure that's remote. So first and foremost, I would say put together a team that has a lot of that solid foundation in the network fundamentals, because this will guide you much more than the documentation will. The other thing is just, keep in mind that there are different philosophies in the different cloud vendors. Certainly Amazon came from something very different than either Azure or Google Cloud Platform. Very different philosophies, very different implementations. But they still have something in common in that, I would say stick to your application. Don't necessarily buy everything they're selling. There are certainly some services from the cloud vendors that I'm extremely skeptical of, and I think it will always be that case because they're always trying out stuff to see what sticks. So, their business is to build the infrastructure. Your business is to build the apps. Lean heavily on your domain expertise. Those are some of the first caveats that come to mind.
And you make a point that I think is worth talking about is, hey, these questions about technologies, the questions about technologies are actually solved with the right people. You get the right people in the room, they will tell you which technologies to use. And they won't be thinking about, here, I love AWS, we're going to do everything with AWS. They'll have that grain of salt that you talked about there.
Right.
So one other paper thing that you wanted to talk about briefly was this paper by David Patterson. It was called A Berkeley View on Serverless Computing. Tell me more about your thoughts there.
Yeah, this is great. So David Patterson, you might know him from a couple of things, RAID and RISC. Certainly when I was a grad student, EECS and working on VLSI, David Patterson's prior work in hardware was he's a hero. Patterson had built out kind of a methodology. You'd almost say it's like a pattern language, but they had this way of interviewing a lot of experts from different kinds of verticals, different kinds of companies, and trying to extract from them what they could see as formalisms for emerging patterns. I think that's probably a good way to put it. And so they applied this when they started to see cloud taking off. And they did this work in, I guess it was 2007, 2008, bringing in a lot of people and putting them through this rigorous process of being able to articulate what are they actually doing in the cloud, and how could they begin to describe some theory for it. So they wrote a paper. It was published in 2009, February 2009, called "Above the Clouds," and that paper turned out to be prescient. I mean, it really described, certainly for the next 5 years, but going into the next 10 years, what the rollout of cloud adoption would be and what some of the major issues companies would be struggling with. Because, I mean, at the time, trying to get cloud adopted in a company was a battle. Um, and it really wasn't until, like 5 years later, that it became something that was relatively acceptable. Um, so that first paper, Above the Clouds, was really interesting because it was relatively prescient. 10 years to the day, in February 2019, Patterson and the new crop of grad students came out and published a subsequent paper. It's called a Berkeley View of Serverless, but it's basically Above the Clouds Part 2. And Eric Jonas is one of the main postdocs driving it. So the story in Eric Jonas was that he'd been such a fanatical fan of cloud computing that when he was in high school, he wrote an AWS simulator from scratch just so he could play with it. Really great guy. I think he's teaching at U Chicago now. But he was a postdoc and he was looking at what are the physics, like what's really driving the economics of cloud. And from that perspective, really a lot of rigor in terms of performance analysis and measuring. He went back into, at the time, AmpLab, now RiseLab. I guess it had shifted over to RiseLab. And he looked and he said, hey, this is where Spark came from. But, not a lot of people here have ever even run a Spark job. And he looked at the machine learning students, and it was like single-digit percentage that, they weren't using Spark. They weren't using a large framework. But they were needing other infrastructure. And so the 2019 paper is a lot of really punching beyond the hype of a term like serverless. Really, what's happening in the world of frameworks? What is the underlying change in terms of the foundations of cloud and the economics of it that will drive a new direction? And so I like that because it really it set a lot of the tone for what's going on in the Ray project, and being able to have essentially a pattern language to describe the fundamental building blocks of distributed systems. How can you mix and match them for a given use case?
And that's really interesting, Paco. Thank you. I really appreciate you being here. We're going to move on to Mikio now. Thank you so much, Paco, and thank you to from the rest of the world to you for your work on that. I appreciate it.
Thank you, Jesse. Thank you, Jesse. Hope all goes well. Hi, Mikio.
Hey, Paco.
Yeah, we
Jesse.
We all know each other. Mikio, thank you. So a brief intro for Mikio. Mikio has worked as a machine learning researcher in the industry, and before he was at Zalando and Get Your Guide. He was an engineering manager there and an individual contributor. He's led data teams to make sure that the initiatives are AI ready. He's starting a consulting practice, so those of you who are watching, you can ask him some deep AI questions. We were going to play Stump the Mikio on this one. And putting how you should put ML into practice. I'd have to say, in your interview, one of the things I appreciated the most was around how you actually got business to understand AI. Could you talk more about that?
Yes. So the way I usually look at these things, I think it's not just the technology, right? Technology is very challenging, but at the end, everybody has to play their part. So they have to, product has to be involved, and then ultimately also, the business leader in a company also need to understand what machine learning is and how to use it. So actually, what we did is we made workshops for top management, for SVPs and VPs, a half-day workshop. There was about as much as we could get into their calendars. And then we try to really hands-on teach them what are the basic ideas of machine learning, what are typical business problems where you can apply machine learning, and I hope that they bring it home, right? Because for them, actually it was very interesting. So for many of them, right, they thought machine learning was mostly about automating stuff, So instead of having people to manage something, you use machine learning, and then you can do it automatically. And for them, sort of, we did one practical exercise where you could sort of manually put together a decision tree. I forgot what it was, some predicting something like customer action or so. And what we wanted them to understand is that these things get so big so quickly, right, that it's really not manageable. And this additional things was not just about automating, but there is also tasks when you personalize decisions and stuff like that. It's really not even possible to do it manually. Right? And I think there was or at least we got quite good feedback on that. And then, of course, it takes quite some time till they bring it back to their departments and sort of use it for their planning and so on. But I think that's definitely where it has to start also.
So out of that, do you think that the business came in with unrealistic expectations and you gave them much more realistic expectations after that?
Yeah, I think not really unrealistic, but more not so well informed, right? So it's complicated technology and it's changing so much. So everybody had some idea what it was, right? But they didn't really, obviously they didn't really fully understand often what it really means, right? Or like how important it is to have data. And sometimes the data you need to train these models isn't available and all these things. Right, so I think it was one other part was where they sort of made an exercise where they brought business models, and then we had like a small like a 3-step test to see like whether the business model is good for machine learning, right? So it's not a secret, right? So I always say, so if you cannot just write a program for it, right? It's something like recommendation where it's not that clear like how to do it explicitly. But there are lots of examples, and then lastly, also if it's not like super mission critical, so you wouldn't want to do like switch your whole accounting to machine learning, right? But something like recommendation, for example, that's a good place to start. And I think that's right. So that really gets people thinking in different ways about like how to solve business problems, and that's important, I think.
So we have a question from the audience. It's from Oliver Ziegerman. He asked, how to accelerate adoption of machine learning in traditional businesses such as insurance and banking?
Good question, yes. I think there's some additional, like in these really traditional businesses, there are some additional like barriers you have to go over, right? Especially like insurances, it's super highly regulated, so they have a much higher need than other businesses to understand the models and so on. But I think other than that, so it's in the end it's like a change process, right? And so so always like you have to start somewhere, you have to prove the worth on smaller problems, like, and then build like a coalition of people who have done it and who can also go into the company and help you make others understand what it is for and so on.
So we have another question. Do you have any guidelines on how to align data engineering, data science, and business teams? All of them have a piece of information to deliver value and is often difficult to align interests.
Data engineers, data science, and so I think at least at Zalando, what we tried was really to sort of have these teams really come together and deliver one product, right? So it's not like, so I think what easily happens, and especially in big companies, is that everybody has different like goals and metrics and KPIs they have to go after, and then of course this leads to all kind of like this friction. But then so in the end, I think it's the important thing to do is that you have all these people and like one goal, and then you maybe derive like individual goals down from that, and then hopefully you find a way to make it work, right? But so it's I think the one thing so data science products and services, it's sort of new still, right? So I think you have to take a more integrated agile approach than other parts. So there are some parts where you already know how to do it because it has been around for a while and you figured out how to do this kind of projects. But data science, also because it has so high uncertainty, right? Because you don't know whether the data is their data quality is good and so on. You have to take a more iterative, agile approach, and that often also means you have to bring more people together than maybe otherwise, right? And I think the problem is if this flexibility isn't there, if people think like this is just another project, let's do it like we always do projects, right? Then it can be quite difficult.
One of the things I appreciated from your interview was how Zalando brought teams together and how you had a progression. So I'd encourage you, so Lucas Lober asked that question, and just everybody in general, as you read that chapter, there was this really good interview from, I think, their VP of engineering. And he talked about how he organized teams,
Oh yeah,
and
Eric
then
Bowman, yes,
yeah, Eric Bowman, thank you. And then that carried over into how the data engineering teams, how the data teams were then structured. Of we actually put the business in there with the data team, and I think that's a real key part of what you'd want to do there, Lucas.
Eric Bowman, who's by the way also was one of the lead developers for the first Sims game. So he came on like 5 years ago as VP of engineering in Zalando and really changed the whole culture. Quite impressive, I think.
Yeah, and he was nice enough. We connected over LinkedIn. I said we are going to have lunch or dinner next time I'm in Berlin. When I'm in Berlin,
Yeah.
I'm going to be optimistic. I will be in Berlin.
Yes. You will. I'm sure it will happen. Yes.
Good. And as far as the other one, the other question, you were too humble to say. You accelerate all these projects by hiring Mikio Braun. That's it.
Yeah, of course. Sorry, I'm new to this. So
He's not a very good self promoter. Do you
yeah,
know
I'm
who
working
P.T.
on it.
Barnum is?
No.
Okay, P.T. Barnum. He ran circuses here in the U.S. and so that
Ah,
was what he always said. You have to be a good self promoter.
yes. Yeah.
So, Mikio, do you have any other gems of wisdom for us now that you've had more time to think about this after the interview we did?
Um, yeah, I think maybe one thing that often comes back to me is um, so I think it often pays off to there's this it pays off to think things through, you know. So often if you start with data science or so, it's really like big change projects, or you have to build up a lot of infrastructure you didn't have before. It's not like you have already something like a website and then you want to have a new feature. And I figured that that's really something that's quite complicated, sort of. So you don't want to have like the whole plan and then have like a 2-year plan and just try to execute it, right? But you also don't want to just go like week to week and build something and then sort of build yourself into a corner. But having that thing, and then especially with everything changing so quickly, being able to figure out like, okay, where is this? If you do this, if you make this technology choice, right? If you go with this service, what will it need? What will it mean for us? Like 2 years down the line, 1 year down the line, and it's really difficult. And yeah, so okay, now I'm trying to, so that's also part of what I hope I can bring as sort of this insight and having seen it in different versions. And you can say, so I know exactly this. If you use this, it's very super easy in the beginning. If you use this service, but then you get into scaling issues or something like that, right? So I think that's really a big challenge today. And for many people, they rather say, okay, let's just try something and see where it goes instead of trying to figure it out beforehand.
So, how much do you think there is a bit of a blindly trying to figure it out versus I know the answer?
I think it's quite a lot, right? Because it's all new technology, right? And then often what the vendors promise is also pretty uh, sometimes a bit more than what it's sort of what they can realistically deliver. And then you just trust them and try it, right? And then like later you figure out, okay, oh, this is actually quite limiting for us. We have to do something else, and then you try something else. So the problem is all these people are trying stuff out, but it takes quite long to see the results and where it's leading to. And I think that's one of the big challenges right now. Yeah.
Excellent. Well, thank you so much, Mikio, for
Yes.
coming on. I
Thanks for
really
having me.
appreciate it.
Hey,
We will
Lars.
we'll move on to Lars Albertsson. Lars, I haven't seen Lars in quite a while too. So thank you again, Lars, for coming. So Lars is the founder of Skling, a data engineering startup based in Stockholm, Sweden. he is Skling, I hope I'm saying that right, is providing data value as a service. So we're definitely going to have to talk more about that and what data value as a service means. So it's customer tailored data engineering, analytics, data science. Before that, he'd worked at Google and Spotify and as an independent consultant. And the contribution that Lars made was successful data democratization. So we'll definitely get into both those topics. So to start off with, tell me more about data value as a service.
Yes. So the business idea came out of a realization that there is a huge gap between the sort of the leading elite technical companies and the value that they get out of data and the ability they have to do things like machine learning. And then you look at the bulk of companies, the trailing companies, which is almost everybody but the elite, and how they work with data and the amount of value that they leave on the table that could have been generated. I worked as a consultant for a few years, and sometimes things go right, and the company they come to is able to change the way they work in order to make benefit from that data, because that's usually what it boils down to, changing your workflows and how you think about product development and so forth, rather than technology. But changing how organizations work is really difficult. It takes a lot of time. And as an independent consultant, it was challenging to try to sway people towards the sort of the right work patterns. So the data value as a service is an attempt to bring the level of data power and data capabilities that from the tech elite companies to the not so technical companies, the retail companies, the manufacturers out there that need it, but without going in and do a cultural change. But in order to do that, we cannot work with the data inside their company. Instead, we say, okay, you want this value from the data, you want reports, recommendations, whatever. If you set up a flow and you give us the data and we work with it together with you, because you know the domain, we cannot know your domain, so we form as a team. But we build the data pipelines, we run them, we host them, and operate them. And then it becomes like a refinery, a data factory. So we take their raw data, and out on the other side comes like refined data in the form of recommendation indexes or reports or analytics dashboards and so forth.
So you mentioned sometimes companies leave money on the table or leave value on the table. What are some of the most common values that they leave on the table?
Well, there's a lot of talk about machine learning and AI these days, but I see so much simple value left on the table just by not doing the standard analytics in a like industrial manner, or not having data flowing through the organizational also in an industrial manner. And that's why my interest of data democratization. As an example, I was shopping at IKEA a couple of years ago. I'm in Sweden, so we shop at IKEA. And I went through their e-shopping experience. And in every interaction, they could have done more with data just through simple means, like sorting the search results by popularity, or filling in the address for me. I was already logged in, or filling in my bonus number, or knowing which store was the closest to me, and so forth. And you could really see through this experience, you could really see the different teams, each had their own little thing, and they weren't exchanging the data. The data was not flowing between the teams. So their organization shone through in the experience. I wrote a blog post about it at the time. And now I went back a couple of weeks ago, and I was buying more stuff at IKEA, and they had completely changed the experience. So now it was customer-centric, and all of the information was readily available. And this is not about machine learning or data science or anything advanced. It's just a matter of getting data to the right place, and that's usually where the low-hanging fruit is.
So let's say a company has done the low-hanging fruit, as you mentioned. What are other types of value that they leave on on the tree, as it were?
So the data mature companies, they have managed to push the cost down of refining and processing data. So if you look at the traditional companies that work with traditional ways of working and tools like Excel or data warehouses and so forth, if they want to do a piece of refinement, like gather the sales numbers or do a projection and a forecasting, they work with like hand tools, manual tools. Whereas if you have the data mature companies, they have an industrialized process, and so each new thing that you want to do, you could do in a traditional company, but you have to put down lots of work. So if in the data mature company, each new forecasting or a new prediction that you would like to do is simple to put into production and get out there, and therefore also the doing things like measuring data quality and repairing the data and so forth is low cost and simple to do. So if you're in a sort of one of the data trailing companies, you can only do the most valuable data processing exercises. But if you're in a mature company, you can go further down into the fat tail of data innovation things. And in my experience, the most valuable things are usually finance related, like sales and reports and so forth. And out on the fat tail, you have the machine learning things, which, to be honest, today have a fairly low return of investment. So you really have to push down your costs of doing things. And in between, you have things like data-driven features that are not necessarily machine learning, like search and A/B testing and so forth.
Good. So let's move on to data democratization. So you wrote a contribution for data teams called Successful Data Democratization. Could you tell us more about how you've seen companies be successful with that effort?
Yes, I have. So if you look at how companies go through a journey from being data novices to going towards sort of the elite data maturity level, which is a journey that takes many years. They usually start out with a data team, right? That's usually the first effort. And I've been in a couple of companies forming this data team, first start. And that team consists of some kind of mix of data engineers or analysts or domain experts or data scientists. And then that team usually does all of the sort of the big data work. And that it tends to expand into a couple of teams, perhaps some specialized, perhaps you fork out a recommendation team, or you fork out the data collection team and so forth. Eventually, a number of years down the road, you get to this maturity where you have a stable enough platform and a desire from the company to have data innovation sort of everywhere throughout the company, and that's the data democratization stage. I went through that stage when I first joined Spotify. So we moved from just a few teams and did an effort to sort of enable all teams within the company to be able to build pipelines and get mature or get value in their different services from processing data offline, typically in the Hadoop cluster at the time. So that was a really successful move.
So is it more, in your opinion, is that successful democratization just a technical issue, or do you think there's organizational issues too?
There are definitely organizational issues, and there are issues in terms of coordinating, both in coordinating in terms of technical terms, like how do you deploy a pipeline, what formats do you have, and so forth, but also coordination in terms of workflows and both sort of technical workflows, like how do you do quality assurance if you affect other people, but also sort of softer workflows, like what are the governance rules that you have to adhere to in order to be able to use all of this data. That some of it might be personal information and so forth.
Well, good. So I've seen very strong opinions both ways. Some people saying data democratization isn't possible, and you saying, yes, it is possible if you do these things. What do you think those companies that aren't doing data democratization right, what are they doing wrong?
So there are a number of factors that that sort of go on the scale side of democratization, and then there are a bunch of factors that go on the other side, and they have too many factors on sort of on the other side. So on the side of tipping towards democratization, you have to be coordinated in the sense that you have to have an agreement on how you work inside your data platform, inside your data lake. You must limit the entropy, limit the number of languages and formats and tools that you use, and so forth. You must have common rules for governance, and these can either be direct rules or sort of meta rules that you have to talk to this team in order to figure out what the semantics of the data is, and so forth. Whereas if you have too much sort of freedom and how should I put it, gratuitous autonomy, everybody can do things however they want with data, then you tend to tilt towards the non-democratization side. And difficult this is depends a lot on the company culture. So, for example, when I was at Google is a very coordinated company. Many of these things are fairly straightforward. Spotify is an autonomous company, so we had to work sort of to some degree against the company culture and really coordinate things in the lake, even though the rest of the company is not as closely coordinated.
So we have a question from the audience from Lucas Lober. Would you go for a centralized data team or a distributed one in the different business areas?
So it depends on your, as I said before, on the stage of maturity that you're at. When you start out your sort of big data journey and moving towards big data ways of working and workflows, that typically happens with a centralized data team, because then you have too many degrees of freedom. So you need to limit them and define, this is the way that we are going to work within our data platform. But as you mature, you get more value out of your data platform if you manage to have data engineers and data competent people out in the business team, so that they are closer to the business value and closer aligned with the business purposes of your organization.
Yeah, you and I definitely align on that. As I've been asked that question, I say the same thing. Centralized, because you need to get those best practice throughout the teams. Otherwise, you'll just cast them to the wind, and those best practices will never. Once you send them out into the world, you can't bring them back.
Exactly.
And you mentioned your time at Google and Spotify, and you kind of mentioned how it was different. What sort of lessons did you take out of those companies and say, yes, I want to carry forward on these?
For Google, the value of data, I started fairly early at Google, 2007, and they were the only ones doing big data. So the value of data became apparent to me. And also the value of engineering productivity and coordinated technical processes. They excel at that. Spotify, that's not one of Spotify's strong sides, but what Google is weak at, Spotify is strong at. So Spotify is really good at getting value out of teams through democratized decision processes and so forth. And also the lean approaches, which are built inherently into the Spotify culture. Throw away anything that isn't necessary and get rid of things rather than add more things. Many big data projects sort of collapse under their own weight of piles of technology. Nowadays, when I work, I try to throw away as much as possible and just use a few components and working in a very simple way, and it works much better.
Well, Lars, it's been great catching up. I really appreciate it. So now we are going to move on to Dean Wampler. Thank you again, Lars.
My pleasure. Bye.
Bye. So, Dean, how are you doing?
I'm doing well. How about you today, Jesse?
I'm doing good. Thank you so much for coming. So I've known Dean for a long time. And since I didn't get your bio, I'll have to give the bio off the top of my head. You wrote the Hive book for O'Reilly.
Mm-hmm.
You're in the middle of writing another book on Scala.
The third edition, yeah.
Third edition, and you used to be at Lightbend, which is the company commercializing Scala and some other things. And in fact, you had the prestigious, I guess, maybe even a Guinness World Record of being the only VP of fast data in the entire world at that time.
Yeah, if you make up an obscure enough title, you can really be quite unique in that way.
Yeah, so you were there for a while, then you went to Ray, Anyscale, who is working with Ray. So Paco mentioned Ray briefly, so maybe we can get you to tell us more about Ray.
Sure.
And then now you're at, Domino Data Lab. Do I remember that right?
That's right.
Right.
Domino.
Okay, so we haven't caught up since then, but excellent. And as far as the things that you wrote two really interesting contributions for the book. One was called Product Teams versus Feature Teams, and the other one was Switching from Software as a Product to Data as a Product. So let's start out with talking about maybe why should managers be interested in Ray? Let's start there.
Yeah, so what appealed to me about Ray was I guess I should say what it is. It's basically a distributed framework initially developed primarily for Python users, but it's supporting other languages now. And it was invented by some AI researchers at Berkeley who were struggling with just finding an easy way to scale these massive training jobs you typically do in like reinforcement learning. They wanted to scale it over a cluster. They didn't want to be experts per se or have to worry about the details of distributed computing. They just wanted easy to use intuitive APIs and good default choices by the back end for scaling work. So they created Ray, and that's what appealed to me really is that it's I think the easiest tool I've ever seen for programmer tool for writing distributed applications. Not as powerful maybe or flexible as other tools when you really need low-level control, but it really was aimed at the market, if you will, that they were aiming it for, and I think it did a great job. And it's reasonably performant. There are some hooks for configuring it and so forth, and it's starting to get a lot of uptake now in like natural language processing libraries like Hugging Face and Spacey, and they wrote their own libraries for like reinforcement learning and hyperparameter tuning. So I think it has a bright future as a sort of infrastructure tool for making it easier to scale data pipelines.
So why would a manager care about that?
Yeah, it's a really good question. It's you would care about it if you care about better productivity for your team, more good default behavior, so there's less that the team has to work on. It just works better out of the box. Anyscale has announced a cloud service for offloading most of the administrative work that you would have to do. So I think in that sense, it's a lot about just solving a mundane problem that everybody has in a way that is more cost effective than some previous options.
Oh, good. So let's move on to the contributions you did. One was about product teams versus feature teams, and you talked about how product teams were inherently cross-functional, that they needed to have a mix of things: product owners, data scientists, data engineers, front-end people, back-end people. Did you talk more about that?
Yeah, this is a trend, if you will, that's not just limited to data teams. It seems to be sort of if you think of these two options as sort of ends of a spectrum, whether you have teams that are organized around building features, and they could even be like dedicated UI teams and more fine-grained, versus having an integrated cross-functional team that's the so-called product team that's focused on the kind of the complete story for some subset of the system you're building. That seems to be emerging as a best practice for trying to get something that's first of all focused on the end user. What it is you're trying to build, what problems are you really trying to solve. Whereas feature teams sometimes can get a little bit caught up in iterating on features or sophistication or whatever, and not really focusing on the most important problems. And also there's both teams have problems with communication in the sense of feature teams often, it's difficult for different feature teams to communicate in an effective way to deliver products. Whereas a product team doesn't have that problem. It has a different problem where if you have different silos of, let's say, user experience or back-end distributed systems, where each of these product teams is kind of going their own way, then you get a lot of inconsistency across the organization that way. So it's not a win-win or an obvious choice sometimes in either case. There's still disadvantages, but it seems that on balance, organizing as product teams, which I think is what Spotify does. I believe that Lars was just on. That seems to be overall the better choice these days.
And what have you seen as some of the benefits of doing a product team? You mentioned they could align better, but are there other organizational benefits that way?
Yeah, I think maybe a couple things in that sense. One is that I think most people like working on small teams that feel a little bit more isolated and cohesive in the sense that they're not part of this massive, they don't feel as much like a cog in the wheel trying to coordinate over a massive organization and all the inefficiencies there. And there is sort of a technical debt aspect to this too. I alluded to the fact that one team could be going in one direction technically on a particular way of doing something versus another team, and sometimes that's maybe not a bad thing if it means that product is delivered sooner, and hence the customers are happier, revenue goes up, all the usual benefits in that way, and then you can go back and think about how do we reconcile the different approaches, or should we not? Should we just let them go their own way? Sometimes what's right for one team is maybe not the best choice for another. There's another interesting thing I think this model solves. I distinctly remember, this was 15 years ago, I was doing consulting on general agile development at the time. And I was in a big financial institution, and I walked past this big partition wall for cubicles. And there was this giant UML diagram on the side of this partition, and they had the customer class. And literally that thing was 4 feet tall, because it was trying to be the customer God class for the entire organization. So it had everything you could possibly imagine that you would want to throw in as information for a customer that would affect some team or other. Whereas I think when you have product teams that are more focused on delivering more focused functionality, they can define their own customer type if they want, and another team can have a totally different, partially overlapping set of fields and methods. And you don't get these monster UML diagrams that are just unwieldy to work with.
I've seen those too, and worked at a company with one. I walked in and I was interviewing there, and I thought, what the heck is that? That's our UML diagram that you have to memorize. Good luck.
Right. Yeah.
All right, so let's talk about how we can switch from a software as a product to data as a product sort of mindset. You talk about how that there's different ways that data scientists and data engineers approach their work, and that there's different types of application architectures, artifacts, requirements, so on and so forth. Could you talk more about that?
Yeah, I think this is there's some obvious points here, and then maybe some less obvious points. As the stuff that we build these days is becoming increasingly data centric, and we're starting to see sophisticated data applications like artificial intelligence work their way into things that normally we weren't really thinking in those terms to do. My favorite example right now is a lot of the apps on our phones actually have some machine learning algorithms behind the scenes, like whether it's recognizing your face or assistive typing, like guessing what you probably are about to type next to make it easier for you to type on a phone. All of these little ways in which data centricity is working its way into all facets of our applications. And I think it's kind of driving us towards rethinking how we architect systems, both to account for that introduction, if you will, to account for the fact that data science organizations tend to work differently than engineering organizations. And hence there needs to be a little bit more, less friction, let's say, and more fluidity between the kind of research-oriented work they do and the engineering work required for production. And I've been thinking actually a lot about a more low-level aspect of this lately. There's this old joke, and I'm going to sort of mosh together two jokes. One is that software development is either copying and pasting from Stack Overflow, or it's writing software to obscure what are basically CRUD actions on a database. If you think about most of what we do, whether we think of it as data or not, there's some sort of input or a query that brings in data, some sort of munging of that data, maybe presenting it to a screen or whatever, and then outputting results somewhere, usually in some persistent store or whatever. And I think if we ask ourselves what is the simplest thing that could possibly work, it always comes back to, can I actually get away with just doing a data query, if it's kind of a more static data scenario as opposed to streaming. But if it's more of a live real-time thing, whether I'm thinking in terms of events or like the flow of data through a system, like new user requests or whatever, a lot of times if we think about this as just data, ETL, transformation, whatever, it actually will simplify our work because it'll help us avoid piling on stuff that ultimately we don't need, like that massive UML diagram that represents the world of customers, all inclusively. I'm working in a big code base at the moment, and I see a lot of places where if we just kind of go back to that sort of, let's call it primitive thinking in a way, it would actually help us eliminate cruft that isn't really carrying its weight. So I think at a high level, the world is becoming more data centric, and that's kind of forcing us to do more data thinking, like stream processing or better ways of working with data at rest. But even at a low level, thinking about what we're doing is really just data processing, I think helps us clarify the way we should build things at all levels of the stack.
And kind of switching gears into your Scala work, I assume you're writing that code base in Scala?
Yeah, this is a Scala code base, that's right.
So now people often ask about languages for data engineering. In the book, I say it's basically three. It's JVM languages such as Java and Scala, and it's Python. Do you have any thoughts there?
Yeah, it's a really interesting question. As much as I like Scala, it's certainly not a data science or in some ways data engineering language as much as Python, but it does give you like the history of running JVMs in production and the performance that comes with it and all that. What I'm interested to see though actually is whether languages like Swift and Julia will gain a lot of traction on the data side. I'm personally not a big fan of Python, and even just in practical terms, the fact that we always end up writing both Python and C++ to get the performance underneath, which is what Ray did, in fact. I think that's a problem that I'd love to see us get away from, where we can just write in a language like Julia or Swift and get the kind of runtime performance that we want without having to drop to native code. So I hope and expect that we'll see growth in at least those two languages. Swift is getting interesting in like the TensorFlow space, whereas Julia is definitely a data language. As far as the engineering side, probably still be mostly JVM based for a long time to come.
Yeah, maybe for the less technical people, why do you think the JVM is a good language for data engineering?
Yeah, I think one reason is that we're really very, very experienced now. We have like 25 years of experience running JVMs in production. We really know how to do it well. A lot of the engineers that you're going to bring into an organization to enable your data products to run reliably in production, they're going to have that background. Certainly a lot of the tools like Spark and Kafka are not only based on the JVM, but also specifically based on Scala to some level. So I think that's one of the main reasons, even though it creates this divide between the data science teams that just want to do Python, let's say. We're figuring out ways to manage that boundary, including, well, here's the other thing. Maybe it doesn't matter anymore what language we use. We tend to run everything in containers anyway, so we can kind of deploy whatever we want as long as we're comfortable running containers in production. And that's solving actually a lot of the integration problems we had.
Yeah, that'll be interesting how containers, I mean, they're really taking over the world and how that plays out over time. Well, yeah. Thank you again, Dean. I really appreciate you coming on, and have a great rest of your day.
Thanks. Great talking to you all.
All right. Now we have Harvinder Atwal. So Harvinder is the Chief Data Science Officer at Money Supermarket. Overall, he's been a data professional with an extensive career in analytics. He previously led analytics teams at Damhabi, Lloyd's Banking, British Airways. He's excited to not just look at the algorithm side, but the people, the process, the technology side. He's also an author. He's published on A-Press, just like I am. His book is called Practical Data Ops, Delivering Agile Data Science at Scale. Welcome, Harvinder. Thank you again.
Thank you, Jesse, for having me on.
So with that, I would have to say, probably second only to Paco, you had the biggest influence on my book because you did so many things for me, and I really appreciate that. You wrote a contribution, you sat for an interview, and you technically reviewed the book. And I appreciate you doing all of those things.
You're welcome. Having authored my own book, I kind of valued very much the feedback I got from a technical reviewer. So I was more than happy to review your book. I think there's some really great points in it.
Good. Yeah, and I guess we could start there. I think you made the book better. In fact, when I emailed you back thanking you, I was thanking you because you brought a great perspective that I really appreciated and made a few sections even better. So thank you for that.
You're welcome.
So with that, let's talk about your Money Supermarket, the interview that we did. In that interview, we talked a lot about friction, and so far in this show, we haven't really talked about friction. Could you talk about friction in organizations?
Yeah, sure. So I guess the world of data has changed quite considerably, even in the sort of 25 years I've been working with data. So kind of like historically, there would have been just a few data sources within an organization, probably from a few operational databases. There would have been some ETL process to bring them into a data warehouse. Everything would have been curated for the end user. And there was a limited amount of sort of analytics use cases. Really, it was just human decision support. So you'd analyze the data, make a recommendation, and maybe it was acted on, maybe it wasn't. But the world has moved on tremendously, particularly in the last sort of 10 years. The number of data sources available that you are sort of capturing data from has grown sort of exponentially. The volume of data has grown exponentially. The use cases have grown. There's many use cases, not just for the sort of traditional descriptive analytics, like BI reporting, but also, the more advanced analytics, machine learning, more advanced AI like deep learning. So that means it's really important to build processes and give people access to that data. But organizations haven't really evolved enough, or most organizations haven't really evolved enough to take advantage of a lot of opportunities. They're still set up in that sort of historic way where data had to be curated, had to be locked down, and you had to have a good reason to access it or even to sort of capture it in the first place. So there's a tremendous amount of friction within organizations between the data consumers who want to use data and the people who manage data and data producers who kind of want to lock everything down. And in some ways, it's easier for them to reduce risk and make sure nothing bad happens by, saying no to everything. So I think that's really the biggest cause of friction when it comes to data and the use of data in the organizations is the fact that organizations haven't really evolved around let's use data as an asset to create positive outcomes and impacts. Let's treat it, sometimes particularly in many sort of financial organizations, as maybe something that's risky, and some of the regulation doesn't really help in this area. It's made organizations a lot more risk averse. So that friction may come from data scientists having to justify why they need access to certain data sets, access to certain software. So many organizations will limit the type of software that people can use. And if you're a data scientist, you often don't know what packages you need to use or what you're going to do with the data up front. So you may want to download libraries from the internet or from a package manager to see what you can do with the data. And there are barriers within a lot of organizations doing that. So, I guess I'm kind of fortunate on Money Supermarket. We've kind of moved quite a long way over the years. We're kind of democratizing that data. We're giving people more and more access. We make it easy for people to use the tools that they want. Obviously, you've got to be careful. You don't want to create some sort of technology zoo, because that is also quite difficult to manage. But within reason, people are free to try out tools and technology which they think will help them do their job and create those outcomes that they want.
Well, good. So your official title is Chief Data Science Officer. Does that mean that you have data engineering under you too, or is that just data science?
Well, historically, until just recently, I was responsible for the entire data lifecycle. So the data management and platform teams, which included most of the data engineers, DBAs, sort of data architects, as well as the data scientists, the data analysts, product analysts, and so on, all sat within my organization. So kind of made a change recently where I've got a little bit more of a strategic role within the organization. So using data science to kind of drive change and benefit across the wider organization, across marketing, commercial, and so on. And we have now got a sort of chief data architect who looks after our data solutions and the kind of the bulk of the data platforms and the data management. I do have some data engineers within my organization, so I'm a kind of proponent of cross-functional teams. I think, the sort of squad-based structure that many sort of product development, product engineering, software engineering teams is kind of very beneficial when it comes to data analytics. So one of the frictions in organizations is, if teams are functionally organized, if you have a team of data engineers, data scientists, data analysts, testers, and so on, work is very difficult to coordinate across those teams. It gets stuck in backlogs. There's prioritization bun fights around why work is more important. Can you pull it out of the backlog? When you have cross-functional teams, particularly when you have cross-skilled cross-functional teams where data engineers, for example, may learn something about data science to be able to do some data science and vice versa, you can keep work flowing. It's much easier to prioritize work. It's much easier to kind of like focus on the outcomes and not political fights around resource.
Okay, so moving on to the other part that you contributed, it was called Data Analysts and Data Science. And this was a part that I hadn't covered in the book up to that point of when would you choose between a data analyst and a data scientist? It was a question I'd gotten, but I hadn't really come to terms or come to a concrete example of when you would choose. What's your opinion there?
Okay, so I guess there's a spectrum of analytics. There's I kind of borrow from Gartner's sort of descriptive, diagnostic, predictive, prescriptive analytics spectrum. And for me, data scientists are most valuable when it comes to predictive and prescriptive analytics. So, things like machine learning and automation of machine learning for decision making, that I see that advanced analytics spectrum is really the sort of domain of data scientists. So when there are problems that require those techniques, that's when I would choose a data scientist. When it comes to the descriptive diagnostics, then yeah, sure, you could ask a data scientist to build a dashboard or a report. They'd be more than capable, but it's probably not the best use of their skills and experience. And that's where a data analyst comes in. They are more suited to those kind of problems where you just want to understand what's happening in the data or why something has happened. So more around the what has happened and why has it happened is where a data analyst is more useful. And inside Money Supermarket, we have people who often join as data analysts, and we upskill and we cross-skill them in the more advanced analytics to create a kind of career path for them towards data science.
Could you talk more about how you do that process of upskilling?
Yeah, sure. There's a couple of sort of different ways. So, one is very formal, which is through formal training, we encourage people to undertake external training, certification. We sponsor people to do masters in data science, and then there's some sort of informal upskilling, which is if you have people who are working in a cross-functional team who are working alongside data scientists and data engineers, they will learn from them, and they will learn tools and techniques and ways of working from them, which is just as important, if not more important, than sort of formal education.
Oh, good. We have a question from the audience for you. It's from Francesco Musio again. Does it make sense to hire a data scientist when you don't have an analytics practice in place?
It depends. So if you want to build an analytics practice, then sure, it kind of may make sense to hire a data scientist. I think there are a few prerequisites. If you're starting from scratch, a lot of organizations make the mistake of they think you can just bring a data scientist in, and they will work some kind of magic with the data, and you will have the full spectrum of analytics covered from your basic reporting requirements through to machine learning. But actually, it can be a mistake, right? So as you mentioned in your book, you need balanced teams. So the data scientists will need support from data engineers. They will want to potentially offload some of the more basic work to data analysts if there's more advanced outcomes that they can drive with machine learning and advanced analytics. And the other thing that often gets overlooked by organizations is just the sheer amount of technology required if you're going to industrialize data science. So you could have one data scientist come in and great, they could do some machine learning on their laptop, find some useful insights. But to me, that's like a science class, right, where you're doing experiments in test tubes. That's very different from if you want to industrialize chemistry, where you're running an entire chemical plant, right? And it's the same with data analytics. There's a big difference between bringing in a data scientist and what's required, the machinery required to industrialize data science and machine learning at scale. And I think a lot of organizations misjudge that. And you also, obviously, there's a requirement to have the data in the first place, right? So, if you don't have the scale of data, there's not really much you can do.
Kind of related to your question, and it's something I talk about in the book. I say you should hire a data engineer before you even hire a data scientist, maybe even analytics, depending on the company. What's your opinion there?
Absolutely. So you need the foundations there, right? So you need the data to be in a good place. You need your platform to be in a good place, because the data scientist is going to be relying on data pipelines. So you often capture data in a format which is really not suitable for data science, and it needs to go through a process of cleansing, transformation, and so on. You could leave that to data scientists, but the challenge there is that they don't often have the training and experience in software engineering best practice, which a data engineer would have. And things that they build will be extremely brittle in that space. So yeah, I totally agree that a data engineering hire should probably come before a data scientist if you don't have the infrastructure there already.
Good. And you brought out a point that I was trying to make. Maybe you could talk about it a little bit more. The difference between software engineering and programming. I define programming as they have a knowledge of syntax, but software engineering is knowledge of syntax and all these other best practices. Could you talk more about that?
So a lot of data scientists, they see coding as a means to an end. So for them, it's you have a problem, you fire up a Jupyter notebook, you start writing code very iteratively until you kind of get to a solution which you're happy with. And that is very different from software engineering, where you're looking at the entire system, if you like, and you're looking at, well, how can I build a robust application? In the case of data engineering, you're building data products, if you like, robust data pipelines. And there's, just with software engineering, there's a whole set of best practices around how you code, reproducibility of code, reproducibility of environments, testing, and so on. There's that best practice that can be applied to data, plus some more, right? So one of the challenges with data is the data is always changing. So unlike software engineering, where, if you code up business logic and it passes your unit test, your integration testing, or regression testing, and so on, you can be pretty certain that it will carry on working in the way that you expect pretty much forever. The challenge with data that you obviously have is that data can change all the time, right? So you may have missing data, someone may change data formats, data schemas in your source systems. You can have unexpected out of range values and so on. So you have to be able to anticipate these and also develop and code expecting these issues when you're in a production environment. So yeah, absolutely. There's a ton of best practice that data scientists can learn from data engineering that that data engineers have developed over a long period of time.
Well, good. And so you've worked and consulted at various companies along the way, Dun Hobby, Lloyd's Banking, British Airways. What were the sorts of analytics experiences that you took out and said, I want to continue that at Money Supermarket?
I guess my work has evolved over a long period of time. So when I kind of first started, it was very much, you have small data and then you try and apply very sort of complex algorithms to kind of really help people make decisions and understand uncertainty. These days it's about, well, how can you use data at scale? So one of the things I learned from dunnhumby was, dunnhumby, for those of you who are not familiar, run the club card scheme for Tesco in the UK. So they were one of the first organizations in the world to really look at loyalty data and monetize it and scale. And they did something very similar for Kroger in the US. And one of the things I actually learned from dunnhumby was that it wasn't the insight that actually generated the value. It was, well, how can you use that data and try and drive an outcome that you can monetize at scale? So they made money from not from telling Tesco what they could do with the data, but from how can you use that data to send the right coupon, for example, to a customer, or sell the right media to an FMCG. So for me, it was kind of that shift from, hold on, let's look at what outcomes we can drive from the data. Well, what are we trying to achieve and work back from there, as opposed to let's dive into the data, see what insight we can pull out, and figure out then what we could do with that insight to drive value.
Excellent. Well, if you need to go, we can drop off. Otherwise, we could go for just a little bit longer.
Yeah, I mean, I'm happy to continue if you are.
Sure. So, and Paco, if you want to join in too, since you're still on, you're welcome to. And this is kind of maybe some more free-form discussion if you'd like. So probably a year has gone by since you sat for that interview. Actually, maybe a little bit longer. What do you think has changed in the field in that year?
I guess technology is always evolving. So, we are going through our next iteration of our sort of data strategy. And one of the great things is that a lot of the cloud vendors are creating more and more managed services in the cloud, which makes it easier and easier to work with the data. So that's great. Technology is becoming less of a barrier. On the flip side, there is more technology. And so, if you want to use best of breed technology, there are still interoperability challenges. The days of just using one monolithic solution are over. So that challenge still exists. But in terms of what's available on the cloud, that's changed, quite dramatically even over the last 12 months. So that's kind of like feeding into our strategy for, what do we want to do going forward.
So Paco, what do you think? Yeah, that was kind of what you were talking about before I had to cut you off before.
Thank you. Yes, I agree. There is a lot changing on in the cloud right now. I think that, Ben Lork and I just did this industry survey about NLP adoption, because we are seeing a lot of dramatic change in the field of NLP since like late 2017, certainly since 2015. But we're seeing a lot more enterprise adoption. And one of the things that was really telling for me was this tension between sort of one-size-fits-all services that the cloud vendors are promoting. AWS has Comprehend, and there's others like it, versus what's happening in the open source side of the world. And for instance, we found that amongst enterprise, more than 50% of the people who had tried the NLP services from Amazon or from Azure were coming back and saying it just doesn't work for us. I mean, it's not accurate enough to even meet the minimum standards for our application. And it's also expensive, and it's sort of all the wrong things, because in that area of uptake of AI, what you want is not to replace people, but to augment them. You want things to come down in cost enough, but be accurate enough to make what your people are doing more valuable. That's how NLP is being adopted in the industry for almost all of the use cases. So I think the cloud vendors really kind of got that wrong. And I hope that they don't continue down this one-size-fits-all path. And if they do, it's just going to open up a lot more opportunity for smaller vendors working in open source to go after long tail, closer fit to the use cases.
Yeah, and that's kind of, your experience is kind of focused on what I've seen as well. The one size fits all, only in very specific use cases. And I talk about that in the book. General purpose versus very either industry specific or use case specific. You can solve those. I don't think we can solve the general purpose.
Right.
Yeah, we can get voice to text out of the box. That's a very specific problem, and it's a hard problem, mind you, but it's a specific problem. What else are one other thing I did that hasn't been published yet was the survey I did around data teams. And actually, I tried to tie value created to how many teams do you have? Do you have all 3 teams? And I'll be publishing that pretty soon. What have you seen around that?
I'm working on a small whatever. It's a large report, let's say. Working on a project with John Thomas out of IBM, and also Will Roberts, common. We've been doing a lot of writing together, and what we're showing is, this cross team aspect is really the crucial part. And frankly, I mean, John Thomas, this is part of IBM's approach to walking into a customer site. How do they get them prepared to start building out more extensive machine learning workflows? What's the groundwork? And I think a lot of it comes down to trust. How can we get the different teams to trust each other? Or at least to be able, maybe trust is kind of a hardcore way to say it, but if the teams don't understand what each other's practices and trade-offs and hard problems are, then they won't trust what they're doing and why. But if the teams are overwhelmed with having to completely learn what all these other teams are doing, they won't get anywhere. So you have to strike a fine balance of understanding how to manage the communication, and also build the trust between them, but also give each other's team some insight into operating metrics and really, are we in a good space right now, or is everybody scrambling around because there really is a problem?
What do you think, Harvinder, who's in the dark?
Sorry, my lights have gone off. So I think more and more organizations are discovering that just having imbalanced teams is not very helpful or very productive. Sorry, let me just see if I can get my light. No, it's not coming up. I think that there is a general recognition. One of the things that we do to try and solve these problems is, we absolutely right. The communication between teams, so between data teams, but also between data teams and stakeholders, is always a challenge. It's always the interface between teams is where you have problems, right? So one of the ways we try and get around that is to create sort of domain-orientated teams, analytics teams. So rather than having people move from project to project, we have long-standing teams and the work comes to the team. So we may have, for example, a customer team who are responsible for marketing and personalization. They get to understand their data domain. They get to work with their stakeholders. They get to share objectives as well, which is really important. And basically you build up that trust and that communication because everyone's working towards common goals. Everyone has common understanding. Otherwise, there's just too much context switching when you're just jumping from one business area to another or one data domain to another. So I think that will be the direction a lot of organizations move in.
So I saw you agreeing on that context switching, Paco. What are your thoughts there?
Well, a big sort of, I hate to use the term North Star, but a big point of guidance for me for the past several years has been that this area that we're working in is really inherently complex. There's a lot of multidisciplinary kinds of issues. We have to learn a lot, and as the challenges in business keep growing, we keep having to learn more and more. And so there's this sort of constant problem of the overhead of cognitive load and what we have to continually keep learning. And it used to be the case if you had a data science team and you were pushing out models, maybe you do some anti-fraud, you'd learn a little bit about the other aspects of the business. But now you really have to understand a lot more in depth about, is it, was it GRC? Basically your governance committee, what are they worried about? But you're also having to learn about a lot of frameworks and a lot of different technologies. And the more and more that you keep putting this load on people of how much they have to continually learn, it becomes impossible. And I do see in enterprise, a lot of people that I consult for, they're between the poor communication in email and chat and the fact that they're just getting piled on with all these new things they have to learn. They don't have time to get anything done. So I think that, from like a mid-level executive, the best thing you could do is to be cognizant of that, really understand that that's a problem, and try to put processes in place so that people from ops and data science and GRC and product design and others can really work with each other without just having these superhuman, overwhelming cognitive load factors.
It's interesting you mentioned that. We had several people on the show talk about that, and there's another case study that's going to be coming out, and we talks about toil, and I think that is the exact right word for this.
Yeah, that's good.
Executives should be worried and concentrating on toil. There isn't, as Harvinder I think just said, there isn't that single monolith. We aren't just using Hadoop anymore, Hadoop MapReduce. It's now those 10 to 30 technologies I've always talked about. So Be careful. Keep that in mind on your schedules. Don't send your teams on death marches. All right. Any final?
I mean, there are good ways.
Any final thoughts there before we close out?
There's one that I'd like to share, or at least throw it out for discussion. Maybe we pick it up later. But I think that, machine learning is not a one-trick pony, but it's kind of devolved into that. There's a lot of over-indexing on predictive analytics. I think, Harvinder, you were talking about this earlier too. But I think we have to get away from just trying to make money by having a crystal ball, because it's very difficult to produce a good, accurate crystal ball and then bet the farm on it. I think that machine learning has a lot further roadmap and a lot more value use of data for this, in the sense of helping teams of people collaborate on making decisions and understanding the context of them, as opposed to just trying to predict the future and then going after whatever seems to be most valuable. And it's a little bit of a philosophical thing, but it does get into some of the weeds that we're seeing in AI right now, of like trade-off between purely data-driven versus, domain knowledge and more rules-based. And the bottom line is we have to have more hybrid approaches, I think.
Excellent. Last word to you, Harvinder, since you've been quiet for a bit.
Yeah, at least you can see me now. I'm really excited about the future. I think, if we look at some of the surveys over the last few years, a lot of effort and resources has been kind of thrown at the data analytics space. A lot of people, most organizations, to be honest, if you look at the survey results, haven't really driven a lot of value from it. And I'm kind of worried that, especially in these sort of tough economic times, people will start questioning the value that they're getting out of their data teams, which I think would be a mistake for the long term, because data has so much value to add to humanity, right? So, a lot of it is, predictive analytics to make money, but sell ads or whatever. But there are so many useful use cases for data, whether it's driving new medicines, or trying to reduce some of the problems we have in society. So what I'm quite really pleased about is a lot of people have recognized these challenges, that they're not technology challenges, they're people and process challenges, and there are solutions for them. Obviously your book is a really great starting place, Jesse, as well, in this space, trying to recognize some of these problems. So I'm kind of optimistic that over the next sort of 5-10 years we'll kind of go through some of the sort of transition to whatever the technology space has been through. We've had sort of similar challenges with the sort of complexity with code and software engineering, and have developed agile, DevOps, and so on. And then we'll start applying some of these methodologies and frameworks to data. We'll start improving some of that ROI that we get in all this investment.
Excellent. Well, thank you so much to both of you and to everyone. Thank you again to the people who watch this live and who will watch this later. With that, thank you and best of luck with your data teams.
Thank you.
Thank you.
Thank you, Jesse.
Thank you.
Bye.
All right. Bye, guys.